How does the refrigeration circuit work inside a heat pump? We'll see it clearly explained today, even for those who don't do this for a living. We have recreated the refrigeration circuit here in an expanded form so you can truly understand how it works. It can work both as a heat pump for heating, but also as cooling. So your home refrigerator more or less has the same components, just a bit simplified. Today we'll instead see how it works as a heat pump, that is, when the machine is heating. Here in the center we have a compressor, the heart of the system, as you can see, in the center of the system. The compressor increases the gas pressure and raises the temperature of the gas, because the hotter the gas, the more it can heat the water. Once the gas is hot and under high pressure, it leaves the compressor and goes into the condenser, where there is a plate heat exchanger that allows the water to be heated. In this exchanger, as we will see in another video, on one side the hot gas flows, and on the other, water flows that heats up through the gas itself. Once it exits the condenser, it goes to the receiver, and once out of the receiver, it goes to the dehydrator filter, which removes moisture. Don't worry, we'll see it in detail, point by point. After the filter, there's a side glass that lets me see if there is moisture inside the refrigeration circuit and the exact state of the gas before passing through the expansion valve, a critical component. In this case, we have a mechanical expansion valve, which we will later cut open to examine to understand how it's made inside, a fantastic tool. Then we go to the evaporator. In this case, there are two evaporators, but they are just examples. This is the classic evaporator for air-to-water heat pumps. In fact, you'll find this in the external unit of the heat pump. It's the typical coil that cools down, and when there's ice, the machine defrosts it. The ice forms in this coil with the fan. In a geothermal heat pump, water-to-water, ground-to-water type, you will find the evaporator as a plate heat exchanger. In fact, on one side, there's the cold gas evaporating, and on the other, there's water from the aquifer or glycolated water from the geothermal system, which is cooled. Why? Because heat is absorbed from the water or air to evaporate the refrigerant gas. Once the gas has evaporated, it returns to our compressor and the cycle starts again. Thanks to this entire refrigeration circuit, it seems complicated, but once you understand it, it's very simple. We managed to give 1 kilowatt hour of electricity and get 5 thermal kilowatt hours, even 8. We've found geothermal heat pumps that allow multiplying the electric energy by 8. Fantastic.